Okay, let's start. So this is second lecture of our class. We have two students came into classroom, so thank you for coming in. And I hope many students come in because I really hope to have a lot of discussion this semester. Before I start the material, I just want to mention that since you enrolled in the university class, the purpose of any university class is not to deliver just the knowledge, but to expand your knowledge. So what I mean by expand is you have to think by yourself and how to integrate your knowledge into a new idea. So I will just keep talking about the material that is over 100 years ago, but it's up to you to create the new ideas. And also, you shouldn't come to class just to listen what I'm saying. You have to ask questions and express your ideas too. So whether or not you come to class offline or online, I recommend you to participate actively in our class. So let me mention briefly about the thing that I just observed for the class. I didn't went through all of the pages of yours, but some of them actually did finish their assignment. So I'm going to introduce some of them. Okay, so I think some students already put their answers to this first question section. So what is a multivariable function and what do we learn from multivariable calculus? So this is very good answer. So it's really elaborate answer and also written in full sentence, and I liked it. You don't have to give a same answer as I gave you. You can put more stuff that you researched on your own. And you can also add more question on below, whichever you think it is proper, then just put it there. And also, I'd like to mention some of the good answers I found on the fundamentals. So this page is designed to ask you what is your project title or what is your purpose of doing that project. This was really good answer. So I will read briefly about the answers putting in here. So I asked what is the fundamental problem that you want to solve, and this student split my question into two parts. So first part is a short-term goal is the following. He brought up his past experience and basically he wants to solve Schrodinger's equation, and long-term goal is to finding a universal elegant theory that explains the universe. So basically, I know that he's physics intended to major in physics, and that's very nice because I get to know his backgrounds and future plans, and also I kind of know what kind of issue he's interested in and how I can help his goal. And then I asked why is solving your problem important to others? So sometimes it's hard to answer this type of question if your project is very oriented in pure science and somehow abstract questions, but I think it's getting more and more important. I'm sure that also based on my past experience, if you are doing pure science research and more abstract subjects, then you really need your explanation why what I'm doing is important to others, because without those motivations, you will lose your own motivations as time goes by, because studying this abstract material, pure science subject is very hard. So you need to have your own motivations that people can also understand and share. So I think this is also good approach. He also split my question into two parts. Short-term goal is the following, and long-term goal is the following. So in the long term, this will inspire people's curiosity. That's a very nice goal, and you can think about how to explain your research results to general people or people with small knowledge, and so on. So thank you very much for sharing your thinking. And this is the main part that I wanted to ask on this page. Well, how are you going to use multivariable function to solve the problem? Because this class is about multivariable function, so we need to learn something about multivariable function, but I really want you to apply the properties and definitions of multivariable function to your project, even if the project doesn't seem like it's about the multivariable function, but you have to find certain connection so that you can apply the property that I teach you in this class to your own project. So it will take time, but it's a nice attempt that multivariable function will, or multivariable calculus always applies to any type of subject. So it will comes up whenever you try to elaborate your question or degrade or break down your question problems into smaller parts. So the final result that you will going to write in your report could be a very small problem that is hanging on the big question that you asked or you intended to solve, but that's okay. As much specific as possible, make your question or project as specific as possible. Then it is easy to approach and easy to write anything about your questions. So I'm sharing this idea, and not many people actually filled out this section, the fundamentals in the project section. But start as soon as possible, because that's, as I said in the previous class, this project is the main deal. So whatever I'm saying in the class with a blackboard is just a story that you can apply or not, but your story is the main stream. So there was one more thing that I wanted to share here. I think it was, there's another fundamental questions. So whenever I see good answers or that the thing that I can inspire other students, then I will leave a comment on the pages or the sentences. Or if you need an improvement, I will also give a comment. So the question is, what is fundamental problem that you want to solve? I'm not sure, but I am interested in nuclear physics. So, and also my ultimate question is to make the fusion stable. So very specific question and specific area, but not elaborated enough. But I know it's impossible to write everything in detail in this short question. So that's fair enough. So why is solving your problem is important to others? Well, there are lots of reasons, so you have to have your own reason. It's a good reason because the energy problem is a global issue. And how are you going to use multivariable function to solve the problem? Also, it's not clear at this moment if what kind of multivariable function is involved in nuclear fusion or in related area, but you have to find anything. So for example, I want to model an energy function with this and these variables, and I want to graph that function. So that involves multivariable function and possibly involves some differentiations and integration of multivariable function. But that's fine. So, so think about more specific question or more specific goal that you can directly apply multivariable function or using multivariable function to model whatever you're trying to understand. And I after I read this sentences, there are small typos. Typos are okay, but you see in my screen I have auto correction suggestions here. So this is given by, as you see, Grammarly, and Grammarly is not basically it's not free app, but you can use most of the functionality of Grammarly in free. I recommend you to use Grammarly or other equivalent type of app, and I'm suggesting you. So another apps here. In the portfolio page, at the end I put some reading stuffs or watching stuffs in case you're bored or looking for other inspirations. So whenever you feel frustrated in writing English, there are lots of writing apps. So one of them is Pro Writing Aid. You probably had email that saying that every student in DGIST can use this Pro Writing Aid for free for 1 year. I think, and not for 1 year. I think it's up to 2022 January. And also, you can use also Grammarly. Like these kind of apps are fair enough. And also, I gave some YouTube channel that I watched and think it's really important to others. So if you have time, read through. So this is it for this assignment review, and I hope other people could give more input to these assignments. And also, okay, I want to mention that you probably less confused than the first time, but still some of us don't know how to do their assignments. So I will tell you how to do this by example. So as I said, you have to always look up what's new on this red page, template for student page. So whenever I update new pages in this red page, I will leave a note on this updates table. So I made a new update. So in today, so let's go into this page. So I said what is added, the page, the graph of function in questions are added, and the page defining a multivariable function in programming is added. So your task is to copy and paste those newly added pages to your own page and then fill out the answers. Let's go to the graph of functions here. So this is in the this is in the question, which is in the template page. So I ask two questions. What is the graph of a function? And second one is, how can we draw a graph of a two-variable function? That will be the content of our lecture today. Maybe not finished today, but after a couple of lectures, you probably able to graph the two-variable function. But you can answer in an abstract way or more specific way how to solve these questions or how to answer these questions. So let me let me assume that I'm a student and try to answer these questions in this Notion. So let's go to the template, and I will, sorry, so let me go to this page, and let's copy these question and answers, and let's go to, let's go to my page, the dummy page, probably at the end. Dummy page, that's my page. You cannot edit, but you can see what I'm doing in here. So I'm going to add question section, a new page in question section. What was the title? I forgot the title, but let me just put a title here, and I'm just going to put a question and answer. Let's say I want to make a little bit nice look of this question and section, same as I put it in the template before. So that will be my copy and paste scheme. So, and then I want to write answer to next to the questions. So my answer to question what is graph of a function is that the graph of a function, let's say one variable function, is, so you notice that I just pull up a equation input tab, right? So how did I do? So you can put a slash, and it immediately shows you list of blocks that you can add into the Notion, and you can use your mouse and cursor to select whatever you want to put, but there is a command that you can automatically select the block that you want to put in. So I put EQ, and it immediately suggests that this EQ command corresponds to the inline command, and I click this, and then it shows that put any command to put in the formula, mathematical formula. So I'm going to put f equals to y equals to f of x, and you see in the main context it shows the formula, not the text, but I have to put a formula. I have to put a text inside of this input here, and then press done, and now I have a formula here. So is the set, and then now I want to put a formula with set symbols, and I want to put that in the separate line, because I want to explain that set in a long sentence. So press enter again, and I will enter block equation. So I want to put BEQN. So there is a block equation here. So almost the same, but let's say you have a TEX mark here and add a TEC equation. So basically whatever you are putting in this block is the TEC language that compiles to the mathematical formula using TEC language. It's not really hard to use once you know a few commands or certain rules to use. I will, whenever I have time, I will teach you how to do this. So for now, let's say I want to put a set, and the name of set is G of F. So you see there's a math formula appears in the actual text here, but I'm putting a LaTeX command here to visualize this mathematical formula. Now I want to put a set symbol, this parenthesis, and if you're just putting parentheses here, LaTeX doesn't recognize this symbol. So you have to, if you want to put this mark, you have to put the slash in front of the symbol. And then, as I will teach you what is the graph of function in detail, I will just give you the answer. It's x comma f of x. It's a pair of points. And in the usual set rotation, you should put a bar in between. The bar is a bar, but if you want to give a little space in between two symbols, then you can put a slash, comma. Then you have a little bit of space created in between these two symbols. And then f of, and then x is inside of the domain D. So the slash in gives you the mathematical symbol that represent the element is in certain set, this symbol here. If you're new to this symbol, that's okay. You can just write a text in here. How do you write a text? Text rm in. So this command allows you to enter any text inside of math formula. So instead of writing in, so if you just write in in this formula, it gives you xin as a math term or math variable. So it doesn't recognize the space. So it's not a good way to write a text. So whenever you want to write, if it is necessary to write a text in the math formula, use this command text rm in D. Okay, sorry, this is slash here. Okay, so what is D? That's done here. And I have to explain D because I used D. Let's make it bigger. Okay, so let me put another here. So where D is the domain of the function f. So it's a good answer. It's an answer to what is the graph of single variable function. But the question is, what is the graph of a general function? Because there are two types of function. One is single variable function, and the other is multivariable function. So you have to answer what is the graph of a multivariable function. That's what we're going to talk about this class. And also you can do the similar thing with this second question, how we draw the graph of two variable function. That's also be in the class right after we finish this. So that's how you do your assignment. I hope I can just auto-generate these pages to each of these pages, but it's impossible unless I create your pages at the first time. So when I just created your pages, I could have copy and paste the contents in the templates, but after then you have to copy paste by yourself to your own page whatever I updated in the template. And also let's look at the today's newly updated assignment in programming. So it's defining a multivariable function in Go. A task is to define a type called MVF. It stands for multivariable function, and I will going to talk about the functions of programming language Go and how they operate, how they use the types and methods inside their programming language. It will take time. Probably you cannot finish this in today's class. There are helper, your senior students who can help you to help you with the Go programming. I will leave contact information on the portfolio after the class. So if you have any questions about programming Go, then you can contact him to help whatever you have trouble with. Okay, any question before we start? Do you have any questions? No questions? Do you have question? Do we have question in online students? Okay. All right, so today we probably have to discuss a lot about the graph of a function. So in that last class, I mentioned that the purpose of learning vector is one of the reason we need a vector is to graph of multivariable function. So think about the graph of single variable function again. So we know what graph is because we know how to graph, how to draw this graph. So usually it looks like this. That's the picture that you have seen many, many times in high school. And whenever you want to graph a function, you need a certain domain. You need an interval where from or to graph the function. So let's say we have interval a to b, and this is our domain of function. So x lies in a, b, the closed one. So if it's closed, and if you want to really rigorous, then you can put a filled dot at the end of the graph. That's a graph. So you can explain what is graph to general people, but if you really want to discuss or communicate with the people who trained mathematically, you have to use their language, mathematical language. So by looking at this figure, how would you define your graph? So whenever you define something in mathematics, it's either function or a set. Everything in mathematical object can be explained either as a function or set. In principle, function is also can be explained as a set, but however, that's too laborious. So, what do you think? What is the graph? Is it a function or a set? So this is a function. We are talking about the graph of a function. So is graph also a function? So you're saying that this, that the graph is this line, right? So what are the line consists of? Points, right? Many points, infinitely many points. So if you collect all the points, it becomes a line. What do you call whenever you have a collection of points? Is it a set or a function? What do you call it, a collection of points? Is it a set or a function?
It is a set.
Set, right. Set is a collection of elements. You can replace that element with points. So the graph is a collection of points. So it's important to say what kind of points this graph contains. So let's say we have point here, for example, at value x. What's the coordinates? X, comma, fx. So I'm not collecting random points. I'm collecting the points which only has the x coordinate x and y coordinate is corresponding to f of x, right? So that's why I'm collecting points whose x coordinate is x, and this x must be in the domain of function. And then y coordinate is not random. There are infinitely many y coordinates you can choose at the x position, but among them I'm only choosing this one where the y coordinate is exactly equals to the value of function. So this set is called the graph of single variable function. We usually write it as a g, and if you need to specify what kind of function you're talking about, then you have to put f as in the notation. So we are talking about the function named f, so this is the graph of f. This is the graph of single variable function. Let's talk about the graph of two variable function. So easiest two variable function, one of them is this form, as I mentioned in the last class. How would you graph this? Oh, wait, let me change the question. Not the how to draw it. How would you define it?
First of all, we should think about third dimension.
Yes.
And actually, to be honest, I don't know how to draw it exactly, but if I were you, I could choose a point of two, which is x and y,
Right.
then draw z.
Right. So x and y is independent variable. These are the points, and these are the required value to determine the value z, which is dependent variable. So we have three variables which to identify any point in the graph, because graph is a set of points which satisfy certain rules. So we have to first define what is graph of two variable function, and how to draw this graph is another issue. So think about, it's the same name, so I'm going to give the same notation here, but it's a graph of two variable function. What was the name, sorry? Juno already mentioned that we need a three-dimensional because we have two independent and dependent. So two independent becomes an x and y coordinates of the point, and third coordinates is the z coordinate, which is the coordinate of dependent variable. But that coordinate is not random because it has to be the value of function at x comma y. So instead of putting z, I'm putting a value of function. And collecting all of this kind of function points becomes the graph. But now there is an issue on choosing what kind of x and y it should be. So for example, as a single variable function needs a domain, this two variable function also needs a domain. We need a set of x and y's where we can move my x and y freely here. So let's say I'm inside of, x is inside of this interval a to b, and y is inside of interval c to d. And that is my set. That is a nice set. Okay, we have a formula for, if we have a formula for f, we definitely know how to find the third coordinate z. Let's try to geometrically understand this set. We have x coordinate, y coordinate, z coordinate. This kind of three-dimensional picture should be familiar to you. But this is actually a two-dimensional picture, but it looks like three-dimensional because we're using our imagination. So it says if I choose x0 and if I choose y0, then I can choose the third coordinate z. How do we choose that? By using the formula of f. Probably it should be somewhere here, z0, so which is f of x0 and y0. Now I have to pinpoint my point whose coordinates are x0 and y0 and z0, and I want to draw it in this picture. So easy way and familiar way is to make a parallelogram inside of xy plane, whatever it looks like xy plane, and then you move up to z-axis by this value. So that's the point x0, y0, and z0. So collection of these points by moving x0 from A to B and y0 from C to D is the graph. You get the graph. So graph is simply a collection of infinitely many points. Drawing that is a different issue, but just the definition is the set of points. So I want to discuss about how to graph the two-variable function. By the way, so before we move on, let's think about graph of another type of two-variable function. What was it? We have one independent and two independent. What will be the graph of this function? So its name is C, so it's C of t. It's not a plus. It's C of t. It's the same thing. So we have three variables. Okay. So the number of independent and dependent variables are just different. The graph of the function c is nothing but t comma xt comma yt, and t might be inside of a certain domain where this function is defined. And that's it. But, well, let's say graph of this kind of function should be in somehow three-dimensional space. Can we lower the dimension where this graph lies in? Can we graph this graph of function c inside of two-dimensional plane instead of three-dimension? So, well, let's say, let's use the same trick that we had in the beginning for the graph of z equals to f of x to ct equals to xt, xy. So if we have t here, and we have x and y coordinate here, so whenever we have t equals to 0, the point x and y are determined, right? So we have, suppose we have x0 and y0 here, okay? And let's say I am at the t equals to 1, t equals to 1. And somehow there is a slice of a plane at t equals to 1 position, which is parallel to xy plane. This is x. And at time t equals to 1, the value of x and y might change. So probably could be in, well, let's say here, x1, comma, and y1. So when I say x1, comma, y1, I'm assuming that my axis is starting from this point. So let's say this is my new x-axis, this is my new y-axis. And according to these x and y-axis, I'm saying that this x1 and y1 lies in this yellow slice of the plane. So when time continuously change, and if the function x and y are also continuous, then we will see that trajectory of this point is moving along inside of the time t. So let's see, like this, okay? But now, what if we are watching? Does it look like eye to you? So if we watch the trajectory of this point as t moves from 0 to infinity, from this direction, where direction is parallel to t and perpendicular to xy axis, xy plane. How does it look like? So we're going to graph here. So this is x-axis here, and this is y-axis. And t-axis is coming right from this blackboard perpendicular, but you don't see it because you are looking right to it, okay? And it starts from somewhere here. So that's when x equals x0 and y0. I'm sorry, x0, y0 when t equals to 0. And it moves on these planes, right, until it gets to x1, y1, right? So when t changes, it actually changes in 3 dimensions, but you can project onto 2-dimensional plane so that you lose how it moves, but you only gain the trajectory, the full line, full passage where the point moves from to. Okay. So you can graph your function, the 2-variable function, if it's 2-variable function with two dependent and 1 independent onto the 2-dimensional plane. Of course, I say again, you lose information about how fast does this point move along this trajectory, but if you just want to see the figure of the graph, this is better because you have a less dimension, and in this way, you can graph the multivariable function with 3 dependent variables with 1 independent variable in 3-dimensional picture, right? Okay. Why FC, not FY? Did I put XC? Oh, sorry. Why did I put XZ here? XY. Right. Thank you very much. So let's say I want to graph xt, yt, and zt. In principle, the graph of such function is a set of quadruple. So for example, let's say if I really want to define rigorously about this graph, it's xt, xt, and yt, and zt with t inside of certain domain. But then if I want to graph this pair of 4 points, I need 4-dimensional plane or 4-dimensional space, but I cannot draw 4 dimensions in this blackboard. However, let's forget about t-axis as if it's a perpendicular to your the perspective, and I only need the trajectory of xyz inside of 3-dimensional space. Of course, doing this doesn't explains your function exactly because we lose the information of how fast does the point move inside of this 4-dimensional space. But we can only get, sometimes it is enough to get the shape of this trajectory. So for example, let's say we started off from t equals to 0 at here, let's say x0, y0, and z0, and it moves along the way up to here when t equals to 1. We usually take this as a shape of the graph of this type of multivariable function. Okay. And I keep saying that doing this is not exactly the graph of function, but it's a nice way to draw it, and there is a drawback of doing this because we lose the information of velocity. But I'm saying that you can obtain your velocity once you know what's the meaning of differentiations. So at any point, if we want to know how fast does this point move along this trajectory, you can simply take the derivative of this function, meaning that you're taking derivative of all 3 coordinate functions, so which represented by c prime t, and now it becomes a vector, and the coordinate of each vector is also given by the derivative of each coordinate function. So you really doesn't lose anything by drawing this kind of picture. Okay. All right, so far that's a definition. Definition doesn't do any good if you really want to solve practical problem. You have to apply it so that you can handle it in programming or or visualize so that you can actually understand in your head. So I want to ask how to graph. So before we move on how to graph, do you have any questions? Any questions from here? Hey, let's think about this graphing thing. So, did you learn MATLAB in a previous course? No? Did you learn MATLAB? So there is if you learned MATLAB, or if you know any graphing tool like GeoGebra or anything else, and think about how does computer graph our single variable function. So we know how the graph should look like, but how does computer actually graph our function? So for example, you have y equals to x squared function. So I want to graph it from 0 to 1. How does computer prints this figure?
They treat it like it is set, so
Right.
They could pick, they could
Uh-huh.
put any domain
Uh-huh.
very fast.
Yes. So you just so it's your computer screen is based on pixels. Okay. So each pixel have RGB pixel has the range of color range, and if you want to graph it as a black, then you set your color red and blue and green as zero, right? Zero is a black, and then for each pixel, you can just divide your pixel from the point where represents 0 to 1, and then for each pixel, you calculate the value, respective value from 0 to 1. So for example, here is, let's say, if it's 3/4, then at this pixel, you compute the value as 16/9, and then you compute what kind of height should the what pixel does represent this 9/16 from this baseline, and then you pick one pixel that represent that, and then you put a color as black, and then you do this for all of the ranges from 0 to 1. That's the one way you can do it in a computer. You can put the color by pixel based on the definition of graph. If you have lots of pixels, you have a high resolution, that's gonna be require lots of computation, and also you cannot even recognize this line because the pixel is so small. If you just put one pixel in the screen, you cannot see the pixel here. However, that's one way to go. What usually a computer does when they are asked to graph a function, a single variable function, they split their intervals. Well, more than this number, like 100 or 1,000. And then for each interval, at the endpoint and starting point, and at the ends of these intervals, they compute the value of function. That's done by the algorithm. And then they pick a point on the vertical side. Let's see. I want to, let's say, make it bigger and bigger. Like this one. And then what they do is simply connect these dots by straight line. Let me make it more this way. So they just connect dots by dots, like this. So if you do this with large amount of numbers of points, it's a set of lines, but it looks like a curve. That's how a computer does efficiently. Now, this is for the single variable function, but the basic ideas are same. We need ingredients to ask computer to graph the function. The first ingredient is the formula. They need to know, the computer needs to know how to compute the y coordinates. What else they need? Domain, right, domain. So some program just draw the graph without you mention the domain. What that means, they have a default domain. They probably, in MATLAB, they probably use -pi to pi as a default domain. If you don't specify any domain to draw, then they just set the domain as from 0 to pi, -pi to pi. But in principle, you need a domain. Do we need any others? What else we need? Do you have answer from Zoom? So this is the point where the human thinking and computers, the algorithm is getting different. I've seen funny video about teaching computer algorithm to small kids, and I think that was a father, and the father asked the son how to write a computer algorithm, or just as if it's you're asking tasks to computer to pour a cup of glass into another cup. So you have to write in a sentence what to do step by step. And human knows how to deal with the common situation, but computer doesn't know how to do this. So you have to be really specific what to do at each step. So we know a formula and we know domain. Then in a human thinking, now we can draw the graph in a continuous way. But as I mentioned, computer doesn't understand what continuous means. So they have to split their domains. Yes, that means they need to know how many domains, how many intervals, or how many splits, right? So let's say I'm taking n stop intervals, then I need to specify how many sub-intervals should I split this given domain into. Okay. And then the rest of the job is to find the points and draw the line connecting these 2 points. Okay. Let's try to apply that to drawing a graph of 2 variable function. How to graph z equals to f of the x and y. So I will graph x, y, z axis for you. And I want to hear your ideas first. How to graph these on the computer.
Basically, it is the same as the former one.
Mm-hmm.
I think we need one more intervals about y.
Right.
So that
Exactly. So we need to subdivide our x interval as well as y intervals. So let's say I subdivide it into n components, and here we have m subintervals. Okay. And what's next? Mm-hmm. Right. We should know the value of function at each point of subintervals. So for example, let's say I pick this point, and let's say I pick this point. Then I need to be able to compute the value here. Okay, yeah. Right? And suppose I did that for every nx values and mx values. Basically, I have to compute my z for m times, right? So, for example, I have points here, I have points here, and so on. So, what's next? Maybe it should be enough, because we have a fair amount of points floating on this three-dimensional space. And as we mentioned, that graph is a set of points. If we just draw these points on this figure, it might represent some kind of figure of graph of function. It's a similar thing with that. If these points are really dense, then we don't even need to put a line in between these points, right? So let's try just to draw the points here. And then if it goes wrong, if it doesn't show a nice picture, then let's think about how to make it better. Or do we have ideas here to try on?
가장 가까운 정렬이라고 하면
Say it again.
Let me think it more.
Okay. I'm saying that this is not only way to graph the graph. Okay, draw the graph. So there are other ways. So we'll talk about that. But for now, let's move on to our this coding here. So at this moment, I will just focus on drawing the graph. But drawing graph, as you've seen already, split into lots of tasks. First of all, you have to plot the x-axis and x, y, and z-axis in some of the canvas. And then you need to specify the formula and domain and the number. That's fine. But for the drawing purpose, you need to know how to draw these points corresponding designated coordinates. So we need three things. First, we need to know how to draw the axis, and we need to know how to draw the points for given coordinates. So in the main package, I will basically work on main package, and then maybe next time show you how to split it into sub package. But for now, I will just work on main function. And here's a moment that I introduce a new package. This is also developed by Go developer, but it's not included in the basic package set. So you have to look up for Go num here. So Go num is the Go package that draws or computes any mathematical things. Especially, you have to go for Go num plotter. Go num plotter, yes. And whenever you search for any outer package, go to the page where you start from package.go.dev here. So it's a documentation page. So I will just go here. Maybe it's so it's about plot, not plotter. So let me go here. The first one. So you see the gonum.org is version 1 and /plot and /plotter. So plotter is a sub-module of plot module. And plotter contains the types and functions that can draw points and lines. So let's see the example here. I'm going to copy and paste the example from this page. If you are going to do by yourself, then you can also mimic this procedure. So basically, let's look at the function main in the example. So it starts from having P as a new plot. So plot is a package in the gonum, and new makes a new type called plot, and we will store that new type as P. So it's an object that has a type plot. So I'm going to copy that. So basically, you can think of this as a canvas that you're going to draw in. And then we don't need all of this. I need to define a point. So let's copy and paste these lines. So now we are using plotter package. Plotter has XY types defined in it. And XYs are the types that contains the coordinates of X and Y. So it's a two-dimensional plot. Basically, whatever you see in the screen is two-dimensional. It only makes it as if it looks like three-dimensional, okay? So everything is two-dimensional. I want to draw a line that represents X, Y, and Z. So think about, I'm drawing that in two-dimensional plane. So I want this point, origin, to be on X 0, 0 place. And let's say I want to draw a line connecting horizontally to the end of y-axis here. So I will draw that in 1, 0. How about the end of z-axis? What will be the coordinate? In two-dimensional. Because I need to set the coordinates of these lines. So erase everything here. First of all, I have to start with graphing the axis in two-dimensional plane. I have to specify my two-dimensional coordinates of these three lines. So for example, I will take a point 0 as 0, 0 coordinates point. Okay, I will choose. I may not be able to draw this arrow sign, so let me just delete this arrow. I will choose the end of this y-axis as 1, 0 point. And let's say I will pick this end of point 0, 1. How about this point? How about the coordinate of this point, end of x-axis? So you can imagine that your picture is somewhere right here. This is our canvas. And the coordinates are here and then -1, right, -1, -1. Fair enough, it's gonna be a good picture. Let's try that. So we start from drawing the y-axis, okay? So I will, I'm sorry, this one is not the one. Okay, so I will connect 0, 0 to 1, 0 and delete everything. Don't worry about the red bar here because I didn't imported this plot and plotter packages yet. And then that's our point. That's a set of points, 0, 0, and 1, 0. And I will make it as a line, so I will use the plotter new line function in the plotter package using these points. So this line does that. The line is the line type inside of this plot package. And then let's not considering the error here, so I don't care about error. Usually it's not a good idea to have handling error, but for now we don't need that. And I will add this line. So far, what I did is in this Go programming, just created a type called line and also added the type into the type called plot. I need to make it as a file to see what happened in this plot. So I have to save this P into the file. So let's go to our example again. The example shows that at the end we have to save it. Okay, so go again. I will save. So the first two numbers are the size of width and height in pixels. So I'm going to have 400 pixel whole 400 pixel size the file, and let's say my name of file is test.png. So PNG is one of the format that deals with the image. So that's it. So let's say save it. So automatically they import these packages. However, if you just installed your Go and then just installed Visual Studio, it will keep giving you the error message. In fact, you have to install this package into your Go profile. Let's go to the package here, package description. Let's say plot package is the main package here. And let's see. The installation. So in the README, there is an installation guide. So you can get plot using go-get. So this command installs from the web onto your computer the package plot. So whenever you just started your Go using Visual Studio, then you have to. I'm sorry, I didn't show you this one. So just go to the documentation, README, and then in the plot package, in the previous that was a plotter package. The plot package is the superior package that contains the plotter package. Go to the README and installation, click it, and then you will see this command to install the Go package. So I will copy and paste that to the console, the terminal. So here we have terminal. Just simply paste go-get gonum.org, or you can just type it, and the last one is ... I already installed it, so it doesn't do anything different, but you have to do this. And then once you save your main.go, these imports will automatically generated. Or you can just simply type in these packages. Now we don't have any red lines. It doesn't mean it means that there's no error. So I'm going to run this main. Go run main.go. So this main.go doesn't have an output string because we didn't use fempty package. However, you notice that there is a test PNG just appeared, and let's draw it. Double click. It says there's a line. There is a line from 0, 0 to 1, 0. If you can see it, there is a legend on X and Y axis, like these. Right? Because whatever you draw in the plotter or plot package, it's a two-dimensional figure. So this x and y axis is automatically generated. But we don't need that because we are going to draw a three-dimensional picture. So if you have such axis, it's kind of confusing. So I will delete that axis. How to delete the axis? So let's look at the documentation types and let's look at plot. So this plot, the plot is the name of type, name of actually a struct type. And this struct type has methods. So one of the methods named hide axis, it hides x and y axis. So it's pre-made methods that you can use really once you import the plot package. So let's apply that. So if you use Visual Studio Code and Go extension, then right after you put H, capital H, there's lots of suggestions. There are hide axis method available. It tells you that you can use this. So just click it and hide axis. And then let's, okay. And then let's save it and then run it again. Go run main.go. So then finished, and you have to refresh. What? Hide axis. Add line. Maybe I didn't save it properly. So let's save it again. Go run main.go. And now the axes are gone. Now let's draw two more lines for x and z. So I will copy paste these, just telling different points to draw. So now I just copied the above lines. And when you define a variable in Go, if it's a new variable, never used before, then you have to put a colon here, equals. However, P is already used and PT is already used. So whenever you do the same, use the same variable, then you cannot put a here. So you just delete this. Okay. Now the red line disappeared. And line is also used already. And I added that line to the plot type. So I don't need to use the information line stored in this line variable again. So I will replace the line with our new line from 0, 0 to 0, 1. So I'm going to reuse this variable. So I will delete the symbol here and add it to the same plot type P. And then that will draw the z-axis. Let's check. Go run main and to get wait until updates. Okay, so you see the lines are on the edge, so you may not able to see it properly, but let's try to draw x-axis, then it's clear. So x-axis, you do the same with different coordinates from 0, 0 to -1 to -1. Okay. Go run main. Did I made any mistakes? I didn't add the second one. I erased this. Okay. All right. Okay. Let's put a space in between so that it's not confusing. Why did I have yellow? Yellow one is okay. So let me just save it. And then wait until they finish. So now we have this. If you like this figure, that's fine. It's kind of, it doesn't seem like it's has the same length, right? So it actually has, the lengths are actually different. So if you want to make the same equal length in between all of this axis, what will be the coordinates here? 1 over square root of 2. Right? Yes. So let's try to change this 1 over. So there is a math package that you can compute the square root and then your cosine and sine. So it's a math.sqrt2 and math.sqrt2. So there is a red bar in between math because we didn't import it math package. We imported it. Okay, so we did that. So now it's gone. Okay, so let's run it again. Now it looks better. Okay. All right. So let's try to graph some formula. So give me some formula to draw. What do you want to draw? So for two variable function. X. Oh, there's a question, sorry. I wonder the difference between, okay, that question was maybe after I explained it. So let me explain it again. So here, where is it? Okay. So whenever you use that name of variable at the first time, you have to put dot here in the column after the equal sign. Otherwise, you have to specify your name of variable is used as some certain type. So for example, let's look at the plot here. So type plot is the type of the, sorry, what was it? I think I made a mistake here. Oh, PTS, so sorry. So I want to use my PTS as a variable for plotter.xys type, okay? I have to declare it first, then use and then use the equal sign here, and we'll assign this value with the type plot.xys to this value. Okay. If you want to, make it simpler, you can just omit this and then put a colon sign. So it's a simple abbreviation of doing declaration of variable. Okay, that's the difference. So once you declare your variable, you have to use that variable with the same type. So you cannot use P as a plotter.xys type or PTS as a plot.u type. You cannot switch that type. All right, so let's go back to the thing here. So what was the formula? Sorry, to say it again. Okay, this is a plane, okay, maybe okay. It could be okay. So let's. Y square. Yeah, y square could be a little bit more interesting. So, how about domain? 2. 0 to 1? Same, 0 to 2, okay. Fair enough. And how about n? Or let's say for simplicity, let's make n and m equal. So let's choose the number of subintervals. Let's start from 10. If it's too many, we can change it later, but let's start from 10. So far we just draw the axis. Now I have to define my formula. So let's say I will define my function as a function, actually real function. So this is how you define a function. It takes x and y as a float type, and it spits a float type value, and it returns x plus 2 times y times y. Okay. All right, that's our function, and let's say domain is from 0 to 2 and 0 to 2. So for simplicity, let's try to make our axis run from 0 to 2 instead of 0, 1. Okay. And then here I have to expand it to, okay, all right. And n and m is 10, so I will just call it n, the same. Okay. So red line, this curly line below f and n means that I declared this name, but I didn't use it. So Go doesn't compile it if I have an unused variable. Now what I'm going to do is drawing a point as we planned. So point for every grid point. So for each point of subintervals, I will compute the z values and then try to draw the point. All right, well, let's do this. For I equals to 0 to n. Okay. So I is the index of x-axis, and I will use j as index for y-axis. If you don't know the for method or anything else, just look at it. I mean, you don't. That's how you learn the language. You don't understand everything into talk. Just talk first and then understand what's going on. Just try to follow this code. And I want to compute my z value as f of what? So we're starting from 0, and we. So what is the number of n? So is it the number of subintervals or number of points from 0 to 2? Subintervals. Okay, so we divide it into 10 subintervals. So we're going to put I minus 10. Sorry, it's 2 times I minus 10. And 2 times j minus 10. So we already defined my f to be the function that takes 2 values of float and spits 1 value of float. So that's fine, but still we have a red line here, which means that cannot use this expression. Why? Value of type int as float 64. That means that I is the int value, and I cannot mix this int value with float value. So I have to force change this int type as float type. Float 64j. Okay. Is that all? Let's see. if I do this, I runs from 0 to n minus 1, right? I doesn't go up to n, so I have to put equal sign here, and that's my z value. And then I have to put a point. In order to put a point, I need to use scatter. So let's go to the documentation again, and is there a plotter? Where's plotter? Let's go to the plotter. Here we have scatter. This type. I'm going to use the scatter. You don't really need to read every documentation here. I will just consult with the example here. So let's see. We have a scatter. How to use the scatter here. So I will copy paste this scatter part. So scatter means just a scatter plot. It just draws the point. Okay. And I'm going to add whatever scatter that is created by the points. Now I didn't define my points yet, so I have to define my points as plotter xy's, the same way we did in the previous. Well, 1 point. Okay, I only need 1 point scatter here because I will draw 1 point. Okay. So the question is, what are x and y coordinates which represent the x, y, z coordinates in three-dimensional picture? So for example, if I move, if I have, let's say, I have to change the screen. If I have a x coordinate as 1/2 and y coordinate as 1/2 and z coordinate equals to 3/4, how would you point? What's the coordinate of the corresponding point in two-dimensional plane? How would you think about that? So in order to draw the point in this two-dimensional canvas, we need to point out what's the x and y coordinate of this point. But we know the three coordinate for inside of three-dimensional space. I have to convert that into two-dimensional coordinate to actually draw it. So this is the time where we need a vector. So let me draw it here. So let's say we have x, y, z points here. I need to know the position of this point related to this origin here. The vector from the origin to this point is called a position vector, and vector can split into sum of vectors. So I will split this as if this is a vector into x 0, 0 plus y 0, y 0, and 0, 0, z. So that means this is equals to x 1, 0, 0, y 0, 1, 0, and z 0, 0, 1. This is happening in 3 dimensions, but I can think about 1, 0, 0 vector as inside of two-dimensional picture as 1, 0. And I can, this is x-axis. So I can think about 0, 1, 0 vector as 1, 0 vector in two dimension. And to the x axis, 1, 0, 0 corresponds to minus 1 over square root of 2 minus 1 over square root of 2, right? And how about z? That corresponds to 0, 1. So to find out the two-dimensional coordinates of this vector in this two-dimensional picture, I have to do the same thing with the two-dimensional vectors with coefficient x and y and z. So let's implement that into our code. So once you see it working, then you can think why it works. Okay. There's my mouse. I cannot find my mouse. Where's my? Okay, I found it. All right. So we have here. X. What is x? Well, first let's put x here. X is this guy, and y is this guy, and z is simply x comma y, right? And let's see. So I'm doing this way. So we have x times minus 1 over square root of 2 times minus 1 over square root of 2, right? And then plus. This is a comment, so this doesn't compile. So I'm just writing this sentence just for my information. And plus z times 0, 1. So after I done this summation, the first coordinate will be my x coordinate here, and second coordinate will be my second coordinate. So let's put my x coordinate as x times 1 minus 1 square root, but square root needs math package, so 2 here. And then here y again. And then there's no first coordinate in z part, so we don't have to put there. And then, let's say we have y. Y is minus x times minus 1 mass dot square dot 2. And now we have z instead of y. That's it, right? So this is our point at x comma y comma z, and I made it as a scatter plot and then added to our canvas. We did it for every sub-intervals using this iteration. So let's see, we have a error here. So we have z is, did I use z somewhere? Let's look at the error message. Missing point, okay, so we have, okay. And now the scatter is the new variable I used the first time, so I have to put the colon here. So I think everything is fine. Now everything disappeared. It should be fine. Let's run our main code. Let's see how it changes. Okay. We have lots of dots. We probably have 11 square dots, 121 dots. But the reason why you don't see everything, probably there is everything here, so, right, okay. So does it look like a graph? Does it show good geometric picture?